Hello and welcome. In this video, we are going to set up and run a static analysis in Abaqus using a simple cantilever beam model. We'll be working with a simple model. Alright, so I'm going to click on standard/explicit model. To kick off, we are going to create the part. The part should be cantilever, and it should be 3D, deformable, solid extrusion, and the approximate size is the size of the sketch, and as the model is 100 millimeter times 10, the approximate size of 200 is okay. So we click on this one to create the rectangle cross section. So we can either write here the dimensions, or what I normally do is to just create a rectangle and assign the dimensions from this one. So we can write 100 here and 10 here, and we click enter each time. It's almost done. We click this cross here and done, and we're going to create the depth. It should be 10 as well, and we click OK. As you can see, here we have a rectangular cantilever. The next thing we are going to do is to go to the property, and from this one create a material. The material, we can write a name, for instance steel, and from the mechanical elasticity elastic, the Young modulus is 210,000 and the Poisson's ratio is 0.33. As you may all know, we don't have any units in Abaqus, but we have to be consistent. So we have the Young modulus in megapascal, and the units of the dimensions are in millimeters, so that we use this number. It's almost done. We have to create a section, let's say cantilever, and it should be solid homogeneous section, and the materials is steel, and we are going to assign the section. So we choose this one and click done, and the section we are going to assign is the cantilever. We click OK. Since it is green, it means the section is assigned. So it is over here. Let's go to assembly. From here we create instance. We are going to create this one. We can either choose dependent or independent mesh. As we have just one part here, I would go for dependent mesh and click OK. In this step, we are going to create a static general step and click continue. Here there are so many things we can change, but for this example I would accept these values and click OK. The next step would be load and boundary conditions. We have no interactions here, so let's create the load first. The load, as I said, is 500 Newton, but this is the force. We have to convert it to pressure, so we have to divide the 500 over the 10 times 100, which is 1000. So 500 over 1000 is 0.5. So we use pressure here, and we click this surface, and the magnitude of the load should be 0.5 megapascal. And the next thing we are going to do is to create a boundary condition. Let's name it incast. click OK. By using this tool, we can rotate our model. So I click escape and choose this side to apply the incast boundary condition and click OK. So this part is completely fixed. We can also, for our convenience, we can have from the toolbars, we can have the views, and we can put it here so we can switch easily from different angles. It is okay, the load and boundary conditions are set. The next step is mesh. From here, seed part, yeah, it's because the model is part dependent. You cannot mesh it from the assembly, you have to mesh it from part. So we can click on part. Now this is green, it means we can mesh it. From seed part, I click seed part, and instead of 10 I would put the value of 1.5, hit apply in OK, and mesh part, it says OK to mesh part and we say yes. Now we can see we have our mesh. It looks good. Now everything is almost done. We can go to the job and from here create a job, say job 1, we name it Cantilever beam and continue. We click OK. From here we can submit the job. I would like to monitor the job after running. So the input processor is completed and the job is also completed. We click dismiss and from here we can see the results. I would like to plot the contours on deformed shape. Let's rotate the model, and as we see here, the model is bent. We also can switch from these views. Yeah, for instance, this one looks good. Also, we can run the animation history, but before doing that, I would like to click on animation option and make it kind of slower and click OK. And as you see here, the transition is being done. The initial condition and the deform condition. Also, you can have both of them by clicking on allow multiple plot states. You can have deformed and non-deformed shape at the same time. So the grayish one is the non-deformed one, and the colorful contour indicates the deformed shape. Also, there's something else you can do, is to go to the option common, and from this one you can have feature edges in order to eliminate the mesh, hide the meshes. So this contour is more preferred, especially in articles and scientific papers. So here we see the maximum of the stress. The von Mises stress is 124 megapascal, as we input everything in megapascal and millimeter. So we have 124 megapascal, and we can see the highest location of the highest one Here, by clicking on show location and hitting apply, we can see that the highest stress is for this node on this corner, which is making sense. In addition, you can see other results. For instance, from stress, you can see the maximum principal stress or absolute value of the maximum principal stress, S11, S22, and everything else. We can also go to the U, which is the displacement. Let's switch back to this view, and you see the maximum of displacement is here. This is the maximum of displacement, and also there are other options you can go and explore yourself. And that's it. A quick and straightforward static analysis setup in Abaqus. If you found this helpful, please give a video a thumbs up and don't forget to subscribe for more tutorials, and thanks for watching.